In my past videos, I did a lot on Euclid. Today I'm going to do Hypatia question 4. Hope you enjoyed this video and make sure to subscribe my channel. Let's get into the question now. So Hypatia question 4 is, let x0 be a non-negative integer. For each integer I is greater than or equal to 0, define xi plus 1 equals to xi squared plus 1. And sub-question A is, show that x2 minus x0 is even for all possible values of x0. And part B is, show that x 2026 minus x 2020 is divisible by 10 for all possible value of x0. And sub-question C is, Parsa chooses an integer n with n is greater than or equal to 1 and n is less than or equal to 100 and random, and says x0 equals to n. Determine the possibility that x115 minus 110 is divisible by 105. Let's get into part 8 now. So if xi is an odd integer, then xi squared would be an odd integer. So xi plus 1, which equals to xi squared plus 1, would be an even integer. And if xi is an even integer, then xi squared would be an even integer. So xi plus 1 equals to xi squared plus 1 would be an odd integer. So either way, xi plus 1 minus xi would be an odd integer. Since we know that xi plus 1 minus xi is an odd integer, and xi plus 2 minus xi plus 1 is an odd integer, then we could know that xi plus 2 minus xi plus 1 plus xi plus 1 minus xi equals to xi plus 2 minus xi, and this would be an even integer. And when I equals to 0, we'll have x2 minus x0 is an even integer. Let's get into part B now. And it wants you to show that x 2026 minus x 2020 is divisible by 10 for all possible values of x0. Since we know that xi plus 2 minus xi and xi plus 4 minus xi plus 2 and xi plus 6 minus xi plus 4 are all even integers, then we'll have xi plus 6 minus xi plus 4 plus xi plus 4 minus xi plus 2 plus xi plus 2 minus xi, which equals to xi plus 6 minus xi, will be an even integer. And when I equals to 2020, we'll have x 2026 minus x 2020 is an even integer, which is divisible by 2. And now let's make a chart in terms of divisibility of 5. So here is a chart. So in the chart, we can see that other than the first term, there is a pattern in the table. xi plus 3 and xi has the same remainder when divided by 5. And this rule wouldn't hold when I equals to 0. Since we know that xi plus 3 and xi has the same remainder when divided by 5, so then xi plus 3 minus xi would be divisible by 5. Also, xi plus 6 minus xi plus 3 would be also divisible by 5. So xi plus 6 minus xi plus 3 plus xi plus 3 minus xi, which equals to xi plus 6 minus xi, would be divisible by 5. And when I equals to 2020, we'll have x 2026 minus x 2020 is divisible by 5. Since we know that x 2026 minus x 2020 is divisible by both 2 and 5, then we can know that x 2026 minus x 2020 is divisible by 10. Let's get into part C now. Part C chooses an integer n with n is greater than or equal to 1 and also n is less than or equal to 100 at random, and sets x0 equals to n. And wants you to find the probability that x115 minus 110 is divisible by 105. So since we know that 105 equals to 3 times 5 times 7, we need to think about it in 3 different areas. So first, let's make a chart in terms of divisibility of 3. And here's a chart. So as we can see in the chart, other than x0 and x1, all other elements when divided by 3 has a remainder of 2. And 110 has a remainder of 2 when divided by 3. So then we could know that x115 minus 110 is divisible by 3. So in this case, every integer works. Now let's recall the chart of divisibility of 5. So we will need x115 minus 110 is divided by 5. So that will require x115 is divisible by 5. And also we know that xi plus 3 and xi has the same remainder when divided by 5. So x1 should have the same remainder as x115 when divided by 5. As you can see in the table, we need x0 to have remainder of 2 or 3 when divided by 5. And now let's make a chart in terms of divisibility by 7. So if we want x115 minus 110 be divisible by 7, then we will need x115 to have a remainder of 5 when divided by 7. So that means x0 must have a remainder of 0, 1, 2, 5, or 6 when divided by 7. So overall, we will need x0 to have a remainder of 2 or 3 when divided by 5. And also, it needs to have a remainder of 0, 1, 2, 5, or 6 when divided by 7. So when n is between 1 and 105, there are 105 times 2 over 5 times 5 over 7 equals to 30 integers that satisfies the above condition. But we need the n that is between 1 and 100. So we just need to find out the n's that is between 101 and 105 and subtract. So between 101 and 105, only 102 and 103 satisfy the first condition, and only 103 satisfy the above two conditions. So then we can know that there are 30 minus 1, which equals to 29 integers that satisfy the above condition when n is between 1 and 100. So then we will know that the chance is 29%. In order to solve this problem, you need some basic number theory skills. If you like my video, make sure to subscribe my channel.